Alright, so can everybody hear me? We good? Alright, so my name is Adam Morgan. I am the lead front-end developer at Seraph Group, which is a seed-stage angel investment network. If you have a lot of money and you want to invest in startups, hit me up. I can connect you with the right people. And today I'm going to be talking about unit testing in AngularJS. Just out of curiosity, how many people here have worked with AngularJS or awesome? I didn't want no hands. So yeah, I wrote a series of tutorials on this website, scotch.io. It's a really good website for tutorials, and I decided to kind of break that down into a quick presentation to show all of you. So first, I'm going to talk about the test tooling landscape. Because I remember when I first started out in web development, I would be reading a post on Hacker News or something like that. I would hear about this new feature in Django or Rails, and I'm like, okay, does Rails replace Angular? Like, I just didn't know what was what. So within the testing world, you have Karma, Jasmine, and Protractor. And Karma is, think of that like NodeMon or Node. That's basically what gets you up and running. You know, you don't really do too much with it other than run your tests. Jasmine is one of the testing frameworks that you can use. There are a few others listed below that. Mocha, Ava, and Chai are some of the big ones. They're all pretty familiar. You know, it's not like you jump from one to the other and you're completely lost. But for the sake of this tutorial, I'm going to be using Jasmine. And then at the end, there's Protractor, which is the end-to-end browser-based testing. So this is what actually fires up a browser, can click around on the application for you, sign in, sign out, actually do functionality. It doesn't just actually test the code itself. And some alternatives for Protractor. Protractor is probably the most common because it was created and it's maintained by the Angular team. But now there are some new competitors, one of them being Cypress, which is a sponsor here. So
Cypress.
I hope I have them in the right silo. I think I do.
We're good.
And then there's also Nightwatch as well. So that should help, kind of get you in the right mindset of what does what. And also, if anybody has any questions throughout this presentation, feel free to raise your hand. I don't mind. As far as why we test, I'll give a personal example. I've been on various development teams in the past where somebody pushes code and then somebody realizes they changed a certain file, and then they go and test and make sure that their code still works, which just shouldn't happen. Your code shouldn't be that fragile. You should be able to push code and have the confidence that it's doing what it's intended. So we test to verify that our code behaves as we expect it to. It'll be very important later on once we get into how and what you're actually testing within your code. And when you test correctly, this helps you to avoid software defects and to avoid manual QA. Again, you don't want to have somebody push up code and then you open up a browser and make sure your code still does what it does and somebody else does what it does. You want to just know it's doing what it needs to. Now within this presentation, I'm not going to talk about all of the setup and everything. That's in the tutorial series. If you need help getting that set up, there's documentation on the websites for Karma and Jasmine, and then there's also the tutorial itself. What I really want to talk about is like the philosophy behind testing, the mindset to get into when you're thinking about how to test your code. And the best example I can think of is to think of like an alien that comes down from space. And let's call this alien Adder. And after talking with Adder, we realized that Adder can really only do one thing, and that's add numbers together. So we ask Adder, we're like, all right, what's 2 plus 2? Adder says 4. And then we go, okay, what's 2 plus negative 1? Adder says 1. We're like, okay, so far so good. We go, Adder, what's 2 plus 0? Adder says 2. When you're testing code, you want to test it in the same way that we test Adder. We don't care about how Adder gets its answer. We don't care if Adder's doing it itself, if it's reaching back telepathically to some alien civilization. We just want to know that Adder gives us the answer that we expect. So if we were to test Adder in Jasmine using the behavior-driven framework we're going to use, are you able to see that? There we go. At the very top, we start off with a describe block that describes what we're going to test. So we say describe Adder, and then we throw a function on the end of that. And then below it, we set up our test cases. What we did earlier was we gave it a few different numbers. We gave it 2 whole numbers, a whole number and a negative, a whole number and 0. And that helps us establish that we're testing adder correctly. And here we have, it should be able to add two whole numbers, create our expectation, and within that we place our code. And then after that we chain it with what's known as a matcher function. And there are various forms of these: to equal, not to equal, to be undefined. A lot of ones that you can see on the Jasmine documentation. I'll be using a few more later on as well. But within each of these if statements, you write out in basically plain English what you're wanting to test, the behavior that you're expecting. And then within that, you actually write your test expectations. So here we have this hypothetical adder with a method add, and then we give it 2 + 2 = 4, 2 - 1, 1, and 2, 0, and 2. And then once you actually get your test feedback, with whatever runner you're using, it actually reads a lot like plain English. So below you can see adder should be able to add two whole numbers. So you get to write your describe block, all of your its, and it should read like plain English. And it really serves as like a documentation for what you expect your code to do. Some brief steps on installation. There's an npm package, Karma. Along with that, you tend to install whatever framework you're using. So here I have Karma Jasmine Chrome Launcher, and then there's also a CLI that helps you run some typical tasks that you want to do, like Karma start, like that. And then similar to the way you initialize a node project with npm init, there's also Karma init, and that walks you through a series of questions, asks you what kind of framework you want to use, what browser you want to use, where your test files are located, and once you're done with all of that, you get this Karma configuration file, which is a lot, I realize, but you really don't interact with this too much. Aside from wanting to add a new library or add some new files that you're going to be testing, you don't interact with the Karma configuration file too much. So, now to step into the actual testing of Angular code. We'll start off with what I consider to be the hello world of testing. Alright, so a lot of this is what's like boilerplate within tests, so this is kind of why I want to start off with this. So at the very top, again, we're describing what it is that we want to test. In this case, we're going to test a users factory, which is just going to return us a list of users that we'll act on within our application. So we start off with a var users at the very top, which is a local variable that's eventually going to be set to the factory we're going to inject into our test. And then below that, we use this thing called Angular mocks, which is provided by Angular, which allows you to inject a module that you've written within your application to be used within this test file. So the before each block basically says before each test, load in this module so that we have it to use. Below that, we have another before each block, which injects the users factory, which we'll eventually define in the next slide, and we set that to our local users variable. And that wrapped underscore is really just syntactic sugar, just to kind of differentiate between users and underscore users on line 7. It's very similar to the way you write directives in camel case, but then in a view you hyphenate whatever words you're using. And then finally on line 10 and 11, we just have a simple expectation that our factory should exist. It doesn't really say anything about it, we just expect the factory to be defined. So in code, it's very simple and it just looks like this. So we have our module that we brought in earlier, we declare our factory, and we declare a variable that's an empty object. We'll eventually write the methods for that, and then we return users. So side by side, API.users is the module that we're loading in that we actually declare over here. Users is the name of the factory that we're actually bringing in. And then because we return users down here that's set to an empty object, it will actually be defined. So here's a quick screenshot of what the application actually builds. The home page. It's beautiful, but it's just a very simple screen that just lists a couple of users. So just to help keep in mind, what we're trying to achieve as we work through some of these next few slides. So if we wanted to test actually receiving a set of users, calling our factory and actually getting a list of users, this is how we would do it. We're building off of the test that was in our previous slide, and really all we're doing here is adding a user list array with a set of users. And then below here, we create an expectation that we're going to call the all method on our user's factory, and that should return a list of users. So users.all to equal the user list we defined above. And then to make that test pass, in our factory, we again create the same array of users that we defined, and then we also create that all method that returns the dummy users. Now this may seem a little weird because it's like, why are we hard coding users? This seems kind of like you just put the same array in both files. But our tests, again, they're about expectations. It doesn't worry about the realness of data. It's not saying, oh, this has to come from an API, this has to come from a third party. It's just saying when you're calling users.all, you expect whatever list of users you've defined. So if you think about our factory being a factory for, say, the 4 co-founders of a startup, if somebody were to go through and change that factory to return 5 users, that test would no longer pass because the test is expecting those 4 users that are specified. So at that point, the coder who went in and changed that array would know either they put that person in the wrong factory, or there was a new founding member added to the team, and that's a change in requirements. So at that point, you would expect your factory and your test to both change because you've added a new founding member. So I hope that makes sense. I know it can be kind of a tricky part of testing. But because of that, because of the way your tests and your code line up, this is why developers often refer to their tests and their expectations for how your code should behave as a design aid for their actual code. Because again, if you're writing in plain English and it's very descriptive, those tests really tell you how your application should be acting in any certain scenario that you're testing. So to build on this one just a little bit more, we can add a method, or we can add a test to find a single user. So all we do is add another single user up top that's just Bob, popped off of the user list. And then way down here, zoom in on that, we add another describe block for our find by ID method, and then we say it should return 1 object if it exists. And then we create another expectation, call users.findById with 2, and say that that should equal our single user. And then within our code, all we have to do is actually implement that. So we have users.findById, and here's where I'm talking about expectations. If you had a different way you wanted to implement this, as long as it returns a single user object, the test should still pass. So if we found out a couple months from now that JavaScript's .find isn't really that performant and there's a better way to do it, you could go in there, remove those 3 lines, replace it with the new way of finding that single user object, and the test would still pass because it's all about the expectation. All right, so testing a controller. We've got our user factory, it returns users, we can get 1 user, but now we want a controller that will actually set that called user to its view model and populate a view like this. So at the very top, we start off with all of our variables that we're going to need to actually fulfill this, $controller, users factory. Those are all going to be set to the various things we're actually injecting into our test. Below that, we've again specified the user list that we expect from our service. And then we inject, or we load the UI.router module component.users, which is going to be our controller, and then API.users, which is the factory we just wrote. Then below that, we inject $controller, which allows us to create instances of whatever controller we've defined within our application. This is built into Angular. And then the users factory we created earlier. So we set both of those to our local variables so we can use them throughout the test. And And then we use this thing called spy on. And spy on basically says, okay, watch this user's factory and watch its all method. And if that all method is called, return this user list that we've defined above. And then after that, we create our we set our user's controller variable to the user's controller we will define, and then we pass it the dependencies that it requires. So the user's factory is what's going to need to actually make that call, and we've just set it to the user's factory that we've injected up here. So down here we actually have our test case, which says that we expect the controller to initialize right away with a call to users.all. And using that spy we created earlier, we can actually do some nifty little things on it, like expect or chain it with something like to have been called, so we can actually verify that the function was called. And then below that, we can verify that the view model object on the controller is set to the users list that we expect, or that we pass it.
Question.
Yep.
So the slide, is that like a mock framework for like
It's spy what?
It's spy on like a mock framework, like
No, I mean it's built into Jasmine, but it's just some additional functionality that's built onto a lot of testing frameworks. So some of them include them, some of them don't, but it just adds some additional functionality on top of expect to equal, so that if you need to verify that certain things were called, but you don't really care what happens after it. That allows you to just spy on various function calls, really. So it's built into Jasmine itself, but in a couple more slides you'll see some other stuff we can do with that. You can actually intercept stuff, prevent stuff from happening. All right, so with that test, the implementation of this is actually much simpler. You can ignore everything from line 9 down. That's a lot of UI router, just state configuration. But as our test stated, we expect a call to users.all, and then we set that to the user's view model object. So users.all to have been called, and then it's set to users. All in that one line. Everybody still with me? Okay. This is going to be a lot, but I promise it's not that bad. All right, so up until now, yeah, I saw some eyes. Up until now, we've just been testing a hard-coded set of users, which honestly mimics the real world a lot, because if you're coding with backend developers and they're doing their stuff at the same time, you're not always going to have an API that you can hit right away. So sometimes you'll ask them, okay, what's going to happen if I hit this endpoint? They describe it through documentation, and then you can create your own dummy users that just get called in your application. But once you actually want to test hitting an API endpoint, which is what a lot of us typically do, this is how you do it. So we're going to use Pokemon Factory. There's a Pokemon API out there. That's what we're going to use because we want to display their images. So at the very top, we have Pokemon, which is the name of our factory that we're going to write. We have the $Q service, which allows you to resolve or reject values and basically make them act like promises. And then we have this HTTP backend, which is kind of like spy on, but it's going to be for HTTP requests. Below that, we specify the API endpoint, and then we establish a sample response success object that we're going to get from the API. Below that, again, some of our boilerplate, we load in our module, which we haven't written yet, but we will, the Pokemon module. And then we inject our factory, inject $Q, and HTTP backend. These are both built in Angular, so we didn't have to write this. And then below this, we describe a find by name method, because this is how we're going to interact with the API. We're going to call it with the name of a Pokemon, and then get a response back. So we establish a var result, which is going to hold the result of our response from the API. And then we initialize by setting the result to an empty object. And then we also do another spy here on the Pokemon Factory's find by name method, but instead of doing mCallFake where we return something we wanted to specify, here we're doing mCallThrough, because if you think about a service method, it's typically whatever the method is, and then within that you return http.get or post or whatever method you're doing. So we actually want to track calls to that, but we want it to continue on to the actual HTTP request. So way down here, we establish our test case. We want to test a valid Pokemon name, so we actually want a successful API call. So we set our search term to Pikachu, and then here we utilize HTTP backend. And what it's basically saying here is when a GET request is made to the API with the search term Pikachu, respond with 200, and then resolve that response object we created up top. So this is just going to wait for a GET request to be made to the API, and once it does, it's going to respond with the response object we created up top. And then here we create a few initial expectations. We expect that the Pokemon by name not to have been called, and we expect result to equal an empty object, which we created here. Then we actually call our service, chain it with then, and set the response to result. And then here's the magic line for all HTTP testing within Angular, because HTTP requests act asynchronously, but within a test it would be very weird to test something that acts asynchronously. You know, we would be like throwing test cases within here, and it would just get really crazy. So what this line does is basically allow you to trigger when you want that asynchronous request to resolve. So everything after that is after the asynchronous request has finished. So if you were to take out this line or put all of this up top, it would go crazy, because it would say the request hasn't finished, you need to wait for that to finish. So if once you put http.backend flush, that basically says take all of our asynchronous requests that we've written in this file, flush them out and finish them, so that now we can create or write our test expectations of what we expect to happen once that's finished. So we expect that the find by name method should have been called with search, which we did right there. And then we expect the result, which we place right there, all the properties to be set to the object we created up top, right here. So I realize that's a lot, but once you do it a couple times, I swear it's not that bad. It's just a lot of code. Yep.
Are you actually doing the HTTP request, or is it just being mocked up?
So it's just being mocked up, and that catches a lot of people off guard, because it doesn't make sense that, wait, why are we testing but not actually making the requests to the API? And the reason you do that is because, again, our test is about handling all of the cases we expect to occur. So if we were to actually hit the API, we would have to wait for the API to fail, which would take a while, right? Hopefully, if we've written our API correctly. But here, what we're doing is we're saying, okay, what are the various scenarios or cases we're expecting? We expect a valid Pokemon to call the API, an invalid, which we'll get to next. And we just want to verify that our application can handle both of those if they occur. So again, if the Pokemon API were to change their response and then that breaks our application, that's an entirely different problem, because they've essentially broken the contract between the two of us. They changed their documentation, we have to update it to reflect that documentation. But until then, we don't actually hit the API, because we want to make sure that in the event of a successful response or an error, that our application can continue on in the way that we expect it to. So if it's successful, display the Pokemon image. If not, display an error. But if we were to actually hit the API, we would just have to wait until it failed. So, does that make sense? All right, so almost done. So all of that, to get that to pass, is that. So again, the find by name, we did that end call through with the spy. That basically says, when this is called, continue on to its internals. And then here, we actually initiate the HTTP request, chain it with then, and return our response. So, not too much. And then, lastly, the error rejection. A lot of this is the same, it's just copied from the previous test file. All we've done is add this response error. This is actually what the Pokemon API returns if you call it with an incorrect name. So again, that's a contract that you have to verify, okay, what's gonna happen if I pass you something bad? What if a user types in something like Atlanta JavaScript and that's not a Pokemon? What are you gonna give to us? So that's the response that we expect. And then way down here, all of this stuff above is the same. I've condensed that initial test we wrote. And then we create our next expectation in case something goes wrong. So we change our search term to Godzilla. Then we modify our backend request just a little bit. So we say when a get is made to the API with the search term Godzilla or anything that's incorrect, respond with a 404 and reject that response. And then below this, we keep a lot of our expectations, but instead of a then, now that it's being rejected, we catch it. Yes?
$Q in the previous test, it said when.
Yeah.
That wasn't a typo, why is it resolved?
When and resolve are actually the same thing. So I guess I maybe should have used resolve. But yeah, q.when and q.resolve do the same thing.
Everywhere, or just
Everywhere. Yeah. Yep. So here, that's all we've done. We've just changed the status code, changed it to reject. And then now when we call our find by name, instead of chaining it with .then, now that it's being rejected, we chain it with .catch. Again, set the response to result, flush it, as always with asynchronous request. And then we create our expectations down below that the find by name method will have been called, and now our result, instead of being a Pokemon object, will be the error response that Pokemon API sent us. I realize that was a lot, but that's the implementation within the factory itself. Again, everything basically stayed the same, we just threw a .catch on the end of that. And that's all for me.